All right, welcome everyone, and thank you for attending the 2021 inaugural EGW Utility Solutions Conference. We know how valuable your time is, and we are so grateful you've chosen to spend it with us today. Before I introduce Mark Cangany to speak about volume corrector solutions, I want to point out a few quick things. First, I want to let everyone know that this session will be recorded, and we plan to make it available to view again later. Secondly, as you may or may not be aware, we're giving away a door prize for every session throughout the conference. For this class, Flow Meter Group has graciously donated a $100 Visa gift card. We'll choose the winner from the list of attendees to each session, so please make sure you're logged in with your real name and contact info if you want us to be able to reach you to give you your prize. Unfortunately, Microsoft Teams does not allow us to unmute individual attendees. All of your mics will be muted throughout the presentation. Don't worry, you can still interact with the presenters by asking questions with the Q&A function. If you look, you should see a button at the top of your Teams screen that looks like a question mark in a bubble. When you click that button and type in a question, it'll come straight to me. At the end of the presentation, we'll have a Q&A session where I read your questions to Mark so he can answer them. If we run out of the time before getting to your answers, don't worry, we'll save the question and contact you directly next week with an answer. Feel free to submit questions as they come to mind throughout the class. And don't worry, submitting questions won't interrupt Mark's presentation, so we encourage you to send as many as you want, as often as you'd like. Sound good? Great. Without further ado, I'd like to introduce Mark Cangany with Flow Meter Group. Mark was born in Indianapolis, Indiana, and has been involved in the natural gas industry since 1986. With a background in industrial instrumentation and controls, he moved to Houston, Texas in '97 for Dresser Industries and began work as a technical training and field engineering specialist. Mark joined Flow Meter Group in 1996, where he specializes in sales and technical for the US and Canada. Thank you for joining us today, Mark. The floor is yours.
Thank you, Daryl. Good afternoon, everybody, and thank you for taking time. I know y'all's time is valuable, so I'll try to make this as easy and as straight to the point as I can. So today, this afternoon's subject is volume correctors or volume correcting. So hopefully we'll give you a little history and what the latest technologies and advancements are today in the area of gas volume correction. When gas volume correcting started, there are two basic physics laws that cover this. One is Boyle's law. Boyle's law deals with what happens to natural gas when pressures rise over a known space, say a 2-inch pipe. So a nice Irish kid, Robert Boyle, in 1662 was the one that developed what we use today for Boyle's law. So how does pressure affect natural gas? The other big law that comes into effect did not really get known until 1787 when a French chemist, Jacques Charles, developed and was able to prove a relationship between temperature and gas flow. So for the sake of today, that's what we're going to focus on. The Charles law and Boyle's law as it affects natural gas flow. So early on, the way that pressure and temperature were tracked was using simple chart recorders. Typically a spiral chart recorder that would run for a predetermined amount of time. Some of the utilities use 7 days, some use 30 days, some use 31 days. These charts were big, they were bulky, they had to be changed out, they were very labor intensive. And in order to turn the charts so that they could be marked properly, a clock timing was used. And those clocks were driven by either a wind-up system or a battery system. Incredibly inaccurate by today's standards, but when they were out, they were leading edge technology. Now we look at flow computers, and flow computers range in availability and in what they can do based upon the customer's needs. We can use an actual flow computer that will take into account many different aspects of your gas flow. But typically in our industry, an electronic volume corrector. This particular one you're looking at is the latest technology. It does have the highest computing power. The processor is very robust, and on a single D-cell lithium battery can last 10 years. Constantly downloading information, watching pressure, watching temperature, applying Boyle's law, applying Charles' law to the actual gas flow so that we see standardized gas flow. This particular instrument can also, depending upon what all you want stored, but hourly data, you're looking at about 112,000 records. And it is a FIFO memory. So the first thing that was in is the first thing it gets tossed. First in, first out. Whereas before, when we had just the chart recorders, the only communications was a tech going in the field, pulling the circular chart, putting a new one on, and bringing that chart back into the office to be read and interpreted. This does it automatically. You can sit in the comfort of your living room and access this volume corrector and get all the information you need, including downloading it. Communication, again, before it was very labor intensive. Somebody had to visit every site that needed the correction. Today, that doesn't have to happen. This particular instrument can have a built-in modem, both cellular and FM, and can be read from anywhere at any given time. It'll also make automatic calls into a server or a distribution server and download its information automatically as you program it to do. Not possible in the old ways. So you can use a corrector both to correct for volume and as a data recorder in real time. It also acts as a safety monitor, if you will, keeping an eye on your gas flow for low pressure problems, high pressure problems, no flow problems. Most people will use a strain gauge type pressure transducer to keep an eye on the pressure. This particular unit uses a piezoelectric, which is latest state of the art. It has almost zero drift and are available in many different sizes to meet your needs. Again, that battery life of 10 years on this particular instrument. If you're data logging, you can have up to 6 analog inputs, low frequency, high frequency, pressure inputs. I even know some people that are using it for security for the fenced area where the gas meter actually is. So they run a contact closure from the opening, the gate, back to the corrector, and the corrector can tell you when that gate was open and when that gate was closed. Overall accuracy with the chart recorders, you were lucky to get 2% accuracy. Now you're looking at 0.5% accuracy, just using the electronics and doing real-time reads. In some of the older chart recorders, and yes, I'm guilty of selling some of them, I won't mention any manufacturers' names, but I sold a manufacturer that was only good to -10 degrees Fahrenheit. Today's electronic instruments, this one included, can handle an ambient temperature of -40 to +180, 158. And what's limiting there is the display itself. Most of the time, they can go below -40 and they work just fine. It's just the display will not wake up. It's just too cold for the display to wake up. If you take a look inside, while it looks very complex, it really is a fairly simple instrument. There is a cover switch, a metrology switch, which really isn't used much in the United States, but it's starting to gain some fans here. Once the metrology switch is turned off, nothing can be done to change any of the settings within the instrument. There is, as I said, a CPU module, different I/O boards, batteries, modems, and it really is a plug-and-play instrument. So if today you don't need a modem, and I don't know, next year, year after next, the boss comes up and says, hey, we need to communicate with those correctors in real time, it's a matter of going out and dropping that module in and adding the extra battery pack or some type of power to power your modem. The modem itself does have a battery pack that's good for about 5 years on this particular instrument. The case and the covers, the case is vented so that you don't get a heat or a pressure buildup inside the case. The ventilation grommets are IP68 rated. There is a seal available. Your seals that you typically would seal a meter with can be used on this. Coax adapters if you want to put a large antenna for your cell modem. If not, you can also get it adapted with a small antenna if it's close in and can get to the cell system fairly easily. Configurations, you can do 1 or 2 meter streams with 1 instrument today, whereas before it was 1 instrument per meter. This particular configuration and manufacturer allows up to 2 for pressure, temperature, pressure and temperature, or pressure, temperature, and super compressibility. As you can see in the lower left of the photograph, there are 2 pressure sensors in this instrument. Likewise, you can put 2 RS-232 modules. You can put 2 temperatures, external power if needed, and 4 digital outputs. The dual battery pack that's installed in here will keep your corrector up and running for about 12 years. So in the United States, typically, all of our correctors are instrument drive. I would say about 96, 97% will set on an ID or drive dog or wiggler, depending upon where you're at as to what it's actually called. These instruments do come with ID available. It does give you a backup mechanical read. It is high resolution, low power. If you have a point in your system where you buy gas part of the year and then you sell gas the other part of the year, it is bidirectional. So it can run forward and reverse, so to speak. It is suitable for both clockwise and counterclockwise drives. When you buy an ID or an instrument drive or instrument mounted instrument from us, we supply the gaskets, the bolts, and the washers. The other way, and starting to see more and more every day, is wall and pipe mounting. So instead of using an instrument drive, you can use a pulse off of your meter to bring in to the corrector the volume passing through the meter. You can also pipe your pressure and then your temperature to the corrector, either as a wall mount, pipe mount, or even meter mounted now. So you don't have to have that instrument drive. Outside the United States, it is rare to find an electronic instrument attached to an instrument drive of the meter. They are typically wall mounted or pipe mounted. And in some countries, they do allow the meter mounting, but they do not rely on the mechanics of driving the volume on the corrector. They rely on a pulse coming out of the meter to the corrector itself. So security, everybody is worried about, and rightfully so. And I spoke about a metrology switch earlier. So on the backside of the door, so the opposite of what you're seeing now would be the actual display, you'll find two micro switches. One is a metrology switch. Once the values are set, that switch can be turned off, so they cannot be changed. The other one is a service switch. So if you need to check your communications ports, min-max settings, output configurations, that switch can be turned on to take care of the work you need to do. Once you're done, flip it down and it turns that off so that it cannot be accessed, not even remotely. In many countries, gas utilities are not allowed to set their correctors. They have to be sent to a metrology lab. The metrology lab sets it up, turns those switches off, and then puts a seal over the top of those switches. Several utilities here in the United States now find that that's becoming more and more valuable to them. So just know that that's available on some manufacturers, but not all manufacturers. The EGW solution does have that, as I'm showing it to you right now. Software data protection. So within the software that's used on the volume corrector, at least this one, there are 5 levels of security. So you can leave it completely open and anything and everything can be changed. Or you can lock it down. The guy in the control room doesn't need to go in and make changes. He just needs to read it. So you can give that kind of access. The field people, you can give access on several levels. Not everybody needs to go in and change the settings within the corrector. Most of the time, they either need to read it or they need to maybe change out a transducer. Those can be done. Those security levels can be set. So again, 5 different levels available. The display. The display is pretty easy to read, very simple. Anything that you can do through the software, you can do through the front panel. And that goes back again to security settings. Where do you want them set? What do you want people to be able to read? Base volumes, corrected, uncorrected, the energy usage, pressures, temperatures, instantaneous flows. This is one of few correctors that will actually give you a flow rate, as well as alarm and error conditions. And if you want to be able to reset those through the front panel, and the condition of the battery. How much longer will that battery last? What few symbols we use are pretty simple and straightforward. The values, you can set them. Do you want to see the leading zeros? Do you not want to see the leading zeros? Does your company use cubic feet or cubic meters? It shocked me in the last 2 years to find out how many utilities in specific areas are now starting to read in cubic meters rather than cubic feet here in the United States. The keypad, pretty simple. It's a 6-button capacitive keypad. It has an enter and has an escape and 4 navigation buttons. As I said before, whatever you can do through the software to set this up, you can also do through the front panel. And the keypad will help you navigate through that. You can look through your local displays pretty quickly. There's no special tools. You don't have to carry a magnet with you to wave over a certain area. But you can't, and you can also lock it down to where it can't be changed. So again, that's where that security comes in. How safe do you want it? Programming. There is a proprietary software. Of course there is. On the L-Core or the LGAS series, the Compass software is given to you when you purchase this from EGW. Other companies sell their software. We don't do that. This particular series of correctors and data loggers is the only true Class 1 Div 1 because there's no electric connection made if you need to program it in the field at the side of the meter. It is an infrared head communicator that slips right on the front. Just walk up, set it in place, a magnet holds it in place, and you can do whatever programming or downloading or uploading you need to do at that time. If there's any diagnostics that need to be done, that can be done as well. And again, no electrical, mechanical connection. Programming. So each corrector, and even the old ones, as well as the new ones today, they require a meter K factor, compressibility calculation method. How are you going to use this with an AGA8, an X19? Those are all available. At last count, there were 9 different compressibility calculation methods available to use, already pre-programmed. You just go in and pick the one you want. Gas composition, set points of alarms. These are all things that in the past just weren't available. They are now. How do you want to archive your stuff? Daily, hourly, monthly? You choose. Communications and settings and protocols. It's very wide ranging with this particular instrument. It is set up as a Modbus, but if anybody has ever used Modbus, just last week I read that there were 57 different Modbus platforms. 57. We can handle quite a few of them. The parameters that can be set are pretty much of your own imagination. Sorry, this one was kind of quick, but are there any questions?
Thank you for that, Mark. We haven't had any, we've only had one question asked so far. Somebody wanted to know the difference between a volume corrector and a automatic meter reading endpoint.
So an AMR is automatic meter reading. So typically, all of the correction is done and handed off to another device, which can then upload to the AMR system. In the case of the volume corrector, a volume corrector is not used on every meter, where an AMR collection point is. This can work in conjunction with AMR systems. It can also work directly to the control room, where you have large volume customers that you need to keep an eye on. We'll take a rubber plant, for instance. You certainly want to know what their usage is every month, and the corrector can give that to you both in actual cubic feet that went through the meter and then standardized. So it already applied Boyle's law, Charles' law, and supercompressibility calculations. Where the volume corrector comes in very valuable is it can watch for events, low pressure, high pressure, no flow, low flow. It can also watch for a number of companies will buy their gas on the open market and use the utility as a transporter. So they say on March 1st, we bought X amount of gas to use over the month. And by the way, we're going to use so much per day and so much per hour. Your volume corrector keeps an eye on that. If they go over, now the local utility can charge for that extra gas used. Whereas before they could only charge a transportation fee, as long as they stayed within their nomination for the month. So a volume corrector is much smarter than just an AMR acquisition point. I hope that answered the question.
I think it should. Thank you very much. Just a minute, I got another question coming in now. One sec.
And did I happen to mention the Irish kid, Robert Boyle? Sorry, I'm Irish,
Yeah.
so.
Somebody asked, what's the typical lead time on your correctors?
Stock to 4 weeks.
Great.
So as y'all know, EGW is in Dallas, and then their guys and gals are spread out all over. We're in Houston. So right now we have a stock a little over 100 correctors. So if you need one, it could ship tomorrow.
Okay.
And my boss has been known to send me out into the driving rain to ship stuff. Can you believe my boss would do that?
All right, we'll give it another minute or two. I've asked if anybody has any other questions. Those are the only ones that have come through so far.
Okay.
All right, just another minute or so, and then we will wrap it up. Anybody has any last minute questions? Now's the time.
Let me add one last point here. So technology has obviously been huge with the natural gas industry in the last 20 years. The pressure transducers that are used in the L-gas complement of correctors, I made mention was piezoelectric. So they don't have a tendency to drift. Those of you that have to deal with correctors, you know what it's like to lose a polynomial file. And oh, by the way, you don't have that saved on your computer, so you have to go back to the manufacturer. And while we're certainly willing to help you out with that, the polynomial files on a piezoelectric transducer is stored on the transducer. So number one, I've never seen, whether it would be a corrector or many other devices that I've used and sold throughout the years, I've never seen a piezoelectric lose its polynomial files. But if you do, again, they're stored on the head of the corrector. It's a matter of hooking up your computer and just telling the corrector, hey, here's the serial number, go get the polynomial files, and the corrector will do that. You cannot do that with a strain gauge type, which is what every other corrector manufacturer in the world uses. We are the only ones that use the piezoelectric pressure transducers, and they're made by us.
So somebody just asked, Mark, if you were the only ones that use the piezoelectric system, and I think you just answered it, but would you repeat that?
Yes. So L-Gas is the only corrector manufacturer that I am aware of worldwide that uses piezoelectric technology on their pressure transducers. L-Gas also manufactures their own transducers.
Okay. We've had two different people ask for a referral list or a users list. Can you give any examples of some current users now, and then maybe send me a list later that I could send out to these folks?
So North Baldwin Utilities, well, I wish Andreas could speak up here. There are 3 in the United States, and we are currently seeking our Canadian approval. There are 9 utilities in Canada that will use them immediately as soon as Measurement Canada signs off on them. We do have a list. Daryl, if you could get their names, I'll be more than happy to supply that list to them.
Okay.
And if y'all want one to try out, let Daryl know. Daryl loves giving stuff away.
We'll give it just another minute to see if anybody else asks for the list or asks any other questions.
Okay.
Those of you that did ask about the users list, if you will respond or send another question with your contact information, I will happily send you that list. You can also email us at events@egwusa.com. It's shown there on the slide in front of you. You can ask those questions or anything about the event. You can also call us at our office there or visit our website, talk to your normal territory manager that covers your area, etc. I haven't had any other questions come in. I was going to give it just one more minute since we've got a little time left.
No problem.
There's one new one. What percentage of European gas companies use LCOR, Mark?
So the L-Gas line of products is the largest selling electronic volume corrector and data recorder in the world. So as far as who uses them in Europe, I would say that is about 70% L-Gas. Asia, you go up to about 90% L-Gas.
So they are definitely not new to the game.
Oh, absolutely not. Peter Kirchill, who owns that company, has been around for a very long time, very well respected. Yeah, he knows our industry well. We have worked with him over the last couple of years to get the corrector Americanized, if you will. You know, in Europe, they don't call this a volume corrector. It is, they call it a, of course, if I hadn't tried to think of it, I'd have told you right off the top of my head.
Of course.
A volume converter, because it converts from actual to standardized.
Okay.
And there are a number of other little idiosyncrasies. You know, we use the term super compressibility. They call it Z pressure, which means the same thing. It's just called a different name.
Yeah. We just had somebody ask if it works underwater. I don't think they literally mean that, but I am curious what the waterproofness or rating is for these. Are they good in outside conditions?
They are fine in outside conditions. So like any electronics manufacturer, 98% humidity, non-condensing. That said, I've seen water run down those circuit boards and the corrector sits there and just chugs away. It is a very thick conformal coating on their circuit boards.
Wonderful.
And I do believe in 2 applications, and these are real wonky ones. They're actually in a waterproof case and a tubing run out of the case up, was it 7 meters to a vent, because the area that these meters are in are so wet.
Wow.
So yeah, it works very well. And in the high humidity and rain, it's just not a problem.
Great.
I've not seen it anyway. Underground, still not a problem. So those of you that have pressure vaults that are underground.
All right. That was the last question. We'll give it just another minute to see if anybody's still typing. All right, nothing news coming through right now, so we will go ahead and wrap it up. I want to thank everybody for coming. I mentioned it a little bit earlier, but if you think of any more questions about this topic or anything related to this event, please email us at events@egwusa.com and we will reply as soon as possible. You can also reach out directly to your EGW territory manager or call our office, whichever is easier. Don't forget, you being here has automatically entered you in the door prize drawing, and we will contact the winner soon. Mark, anything you want to say to close?
I just want to thank everybody from their time. I know these are really dry subjects and not really fun to listen to. Unfortunately, they're necessary in our business. And thank you all very much. And I want to thank EGW for having the foresight to put on this utility conference. I think it really makes a difference in our industry, and thank you to EGW.
Thank you, Mark, for being here and for sharing your insights. And another big, huge thank you to all the attendees. We certainly appreciate you being here. We hope to see you in the next session. Everyone have a good afternoon.